today is we're gonna basically like focusing on this visualization aspect. And then, so in order to get into here, so first, like I want to make sure like everybody's on the same page about EDA. So what is EDA? Exploratory Data Analysis sounds kind of familiar. Exploratory Data Analysis is nothing but an exploratory and iterative process of asking many questions and find answers from data in order to build better hypotheses for explanation and prediction and control. So what that is, so like it's kind of like this, right? So when you have the data, you have questions and you ask the questions of the data, you get the answers by analyzing the data, by visualizing the data, whatever. And then like eventually like you start building the hypothesis. And this is an iterative process, and then like, you're going back and forth and back and forth and so on. And but before though, like why we do the data analysis? Well, like usually like you have a goal, let's say like you want to grow the business, and then like you define the problems to achieve that goal. So like for example, one of the things may be like you want to increase the number of the customers, and then like in order to be able to, oops, there's some Japanese here, to be able to solve the problem, like you want to quantify so that like you can address the problem by using the data. So in this case, let's say like number of customers, and then like you want to you have two things. Let's say like you might want to predict, so like how many customers we will have, you know, and by end of this year or something. Let's say the customer will be 1,000 or 2,000 or so. So you want to do the prediction. Or you might want to control. So the control is kind of like the opposite. So let's say like you want to achieve the customers to be 1,000. Then like your question would be like, what can we do to make that happen, right? So to do the prediction or control, like you want to build a hypothesis. And building a hypothesis, there are two kind of things here is happening. In order to predict, you want to find a correlation, or you want to find like an association, like between the variables. And then in order to control, you want to find not just a correlation, but also this is more like to do with a causal relationship. If you do one thing and then like that will make the different things in the as a target. So for example, let's say like if you want to do the prediction, like maybe the weather becomes warmer, then like your number of the customers will increase because the weather and the number of the customers happen to be correlated. Therefore, like if you know the weather, you can predict the number of the customers. On the other hand, the control is that like you actually take some kind of actions. So like let's say like you offer a 10% discount, and then that will increase, that will or will not, but we don't, but if there's a causal relationship, then like that will increase the number of the customers. So once you have the hypothesis, then like you want to use the data and make sure the hypothesis is valid, and you do, you know, like a statistical test and so on. And this is called confirmatory analysis, right? So like you have the hypothesis and you use the data and test it and then validate it. But the question here is how can we build you know, these hypotheses? And then like if you offer the discount, if the weather becomes warmer, those can be like intuition based on experience, or like you want to actually use the data to come up with this kind of hypothesis. So the exploratory data analysis is about like building this type of hypothesis by exploring the data from the data. So therefore, what is EDA? So I think that the second part of this sentence is to build a better hypothesis for explanation, prediction, and control. So having said that, so I want to actually use the data to kind of demonstrate, you know, like a whole, you know, visualizing the data for the hypothesis building. So today, like, we're going to use the employee data. So there are about like 27 columns, and then 1,470 rows, and each row represent each employee. And then like, there are a bunch of columns, and or we call it like variables, and it's basically the same thing. And then it can be like what is the age, what is the monthly salary, like what is that like a department he or she is working for, type of information. Okay, so the goal here is we want to explain how the salary is decided. And also we want to predict the salary based on the attributes. And this is, And then we want to control to increase the salary if possible. So these are the goals. And then, okay, can we, basically that's the goal, but today we want to start building hypotheses by visualizing that data. Okay, so the EDA, going back to the EDA, what is EDA? So the first sentence of that part, this whole thing is that asking many questions and find answers from data. So, and then then here is a John Tukey, who is the father of exploratory data analysis, and his comment is that like, the far better and approximate answer to the right question, which is often vague, than an exact answer to the wrong question, which can always be made precise. So, how can we define, or how can we come up with the right questions? It's always it sounds simple, but it's actually the most hardest thing to do in the whole data analysis. In other words, if you have the right question, then the whole data analysis becomes much easier. So what are the questions? The two principal questions for EDA, exploratory data analysis. The first is how the variation in variables. Okay, let's understand this variation. So the other questions is around this data variation. And then the second is how are the variables associated or correlated to one another. So these are two things, these are two principles. And once you have this, and that makes it easier to start exploring the data. So, and the best way to explore the data is, again, here's a John Tukey's comment. Since the aim of exploratory data analysis is to learn what seems to be, it should be no surprise that pictures play a vital role in doing well. So he also came up with various ways of visualizing the data as part of the exploratory data analysis. So that's the contents that's the things that we want to take a look at today. Okay, so visualizing variance and correlation. First, let's start with visualizing the variance or variation. So data varies, right? So okay, when you have like let's say like a monthly income, and monthly income never be just one single number. Some people make 1,000, some people make like 15,000, right? So when you visualize by using a histogram, like the average is maybe around here, indicated by this red dotted line, and then but as you see, there's a bunch of different numbers or monthly incomes that people are making. So questions for variance. So we want to understand is what are the typical values? Are there any outliers compared to the general trend in variance? Or how the data is distributed? Or are there any patterns you can spot in the variance? So these are the type of the questions that are around the variance. But like what we are trying to do here is trying to understand the variance. And in exploratory though, actually, when you go to the summary view, there are visualization of the charts are right there. So you actually don't need to do a lot of things around here because it's already automatically done by importing that data. And then these chart types are decided based on the data type. So for example, when you see the character data type column, you see the bar chart. When you see the numeric data type, you see a histogram and so on. And then, but you might sometimes want to more explore in detail. Like summary view gives you only the kind of super like high level things. You might want to start getting to more like a sort of like a customized charts and then start seeing the pattern from your perspective, right? So then like these three charts are suggested or recommended to understand the variance, right? Help you understand the variance. So histogram, density plot, and bar chart. So which charts to pick? Well, it depends on the data type. So what is the data type? Well, so numeric, character, date, and there are a bunch of different data types, but mainly the two data type in terms of like the kind of nature of the data. So one is continuous and the other is categorical. So what is continuous data? So continuous is nothing but it's like a numerical data. So like it can be numeric data type, integer, double, those are the data types. Those are the kind of like technical terms for the data type. But in the nature, if you want to talk about nature of the data, the numerical. And then the other is a date and time, like for example, like 2019, February 9th, and February 10th, February 11th, and so on. Those are continuous as well. So like numerical is a continuous and also ordinal relationship among the values, right? So like this is nothing special about it. So now, so in order to visualize this type of continuous variables, histogram and density plot are really useful. So let's start looking into this things. So histogram is nothing but it splits numerical value into a set of so-called bins, or it can be like ranges with equal range. It shows the size for each, and it shows the size for each bin. So when you have, let's say, like monthly income or like age or whatever, like you split into like a, you know, n numbers, let's say like divided by the 10 or something. And each range has equal widths, meaning, for example, like age is a good example. Let's say like from like 0 years old to like 60 years old, and you divide by, you know, maybe like 10, and then like each range has only like 6 years width or like the size or some range or something. So I think it's better to just start looking into this thing. So like visualizing variance with histogram, right? So visualizing the variance, let's start getting to understand monthly income. So 3 things. First, we want to visualize the monthly income sort of distribution itself, or the variance itself. And then the second, we want to see if there's any difference between a male and a female, like we have a male employee and a female employee. And then number 3 is there any difference between the job roles or like among the job roles? So that's what we want to do. Okay, so let's get into the exploratory here. So this is a summary view. This is the one that I was talking about. So by going here and find a monthly income, where's monthly income? Oh, here. We already see that monthly income seems like the value starts from 1,000, and then like the biggest and highest is at 20,000, and then like a median or like a average is 6,000, median is almost like a 5,000 or something like that. Now, like you can click on this icon, or you go to the chart view to start building this histogram, get into more detail of the histogram. I'm going to click on this chart icon, and then here is the default histogram. And the default is that we can count like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So monthly income is the values are divided into 10 different classes or different groups, and each group, and then now the height of each group is determined based on the number of roles, in this case, number of employees. So we can say like from 1,000 to almost like a 3,000 monthly income range, we have 365 employees. And so on. And it seems like there is a kind of one mountain here, and then I thought like it was like a number of the employee goes down, but at the end, the number of employees actually goes up. So like what's going on here? Well, we can actually change the number of bins. So let's say, for example, here, I'm going to just change to like a 50 and type the enter key. I hit the enter key. And then like now, like basically we have 50 bars here. So that means divided into 50 groups on the monthly income scale. Now we thought like there were 2 groups. I thought there were 2 groups, and then now looks like there are more different groups here. When I said group, meaning there's almost like some kind of like a mountain, because there are a couple, you know, like 5 or 6 mountains or something. If I change this number of the bins to, let's say like 100 or something, and then that can be even more significant. So like, for example, here, this mountain, and then it looks like there's 1 and then 2, 3, 4, 5, 6, 7, 8. So like it seems like there are different sort of like clusters just by looking at this variance of the monthly income by using a histogram. So the second question is, so what any difference? Maybe, you know, let's say like maybe like male employee are making more money than the female employee. That's why like we have like a different type of clusters that we can see here. So let's say like at the color, like we can assign different type of data, different variable or column. So in this case, let's assign gender. And then the female is blue and the male is orange. And it seems like it's not like clear to our eyes the difference between the female and the male in terms of the variance of the monthly income. So we can't really say from here. It's hard to see any difference between them in terms of monthly income. And how about changing that to job role? So here. And by changing the job role, now I can see here is like a red histogram group here. And the red is what? Is here's a manager. So the manager group is kind of towards to the right side. That means they're the one who are making a lot of money compared to other employee. And then at the bottom area, so I see like a pink and then this color, like it's kind of like a yellow-green color. So these are like a sales representative and also here the research scientist. And these guys seems to be making much less money compared to, for example, like a manager class. So this might be one reason that like why we see sort of like a different mountains. So whenever you see the different like type of the multiple mountains, that means there's some kind of category or some kind of groups in that data. Sometimes that group can be represented by one variable or one column, or sometimes it's not that clear. But nonetheless, there's a nature of the data might have some kind of like groups or clusters in it. So here, so like we can see that, and then another way to look at this same type of distribution or variance is something called density chart or density plot. So histogram is great so far, but the problem is when you start having like multiple groups, for example, in a color, it's hard to say, for example, this gray and green, like what is the green and gray difference? Or like I can slightly see like this blue group behind different colors because each group has different color and then they are overlaid on top of each other. So therefore, it's kind of hard to see the difference between the distributions. And then that's where like, so I'm gonna change to the density plot from histogram. And the density plot gives us the sort of like estimated density on all the x-axis. So for example, in this case, monthly income. And then like this y-axis, so under in each group or each line, let's say like this like a yellow-green color. And then the area, the size, what do you call it? Like the size of that area is basically the 1. And then like, we can see like how much of the data should be here in terms of kind of a percentage-wise. So for example, this job role, sales representative, and then it starts from around 0 to like about like 6,000 or 7,000. And then it's relatively small, sort of narrower compared to this orange. Orange starts from 0 and or even like -0, the negative numbers, to all the way to here, like 13,000. So because its area is always the size of 1, so therefore, like when you have the wider and then like the height tend to be shorter, and then like when you have like a lower length or narrower range on the x-axis, that means the mountain becomes more like steep and then kind of high, much higher. But nonetheless, here now like it's easier to see the difference between among the job roles. So for example, here's a manager, and then like a manager is something that like is basically the same thing, but not just a manager. Here we can see the research director. Research director is also making higher range of the monthly income compared to others. And then here like you can see like blue, which is a healthcare representative, and a purple, manufacturing director, and then sales executive, and it's gray. These three, these are kind of like a medium range, is a kind of like a middle range. And then there are these like 4 different colors or different 4 job roles. They are the lower range of the monthly income. So it looks like we can see like job roles, playing a huge role in terms of like monthly income, which is, not that surprising. But by doing so, like it's easier for us in terms of like understanding intuitively by using our eyes to spot the differences. Okay, so that's about those are the visualizing the continuous data variation. And then the next one is the categorical. And this one is actually nothing really so special about it. This is probably most of us, most of you have been doing. But the categorical is just think of it the categories, right? Or like a character base, for example, Texas, California, New York, those are United States. And then these data don't have the continuous relationship. There's no like a California 0.123 or something like that. And also typically there's a limited set of values. Like in the United States case, is only 50 states or 50 plus one or some whatever. And then there's no ordinal relationship. It's not is in just that state name itself. Right. And in this type of the data, we call it categorical. And then that's where like you can use a bar chart. And then again, because this is bar chart, like most, everybody almost like knows the bar chart. So like nothing special that, what you have been already doing. And then here's a visualize the variance with the, what is this? Why is density plot? This is not the density plot. Okay, so the title was wrong. I gotta fix that. But you want to pick the bar chart, and then the x-axis. This time, instead of like a histogram case or density plot, we put monthly salary at the x-axis. But here we want to put like job role, and then we want to understand the variance. It's not like this relationship between job role and the monthly income. We want to understand the variance in the job role. What that means is like which job role has more employees than the others. And then here we can even like sort. By using a sort by, then like we can see like, okay, in this company, in this organization, we have more sales executives than the other job roles. And then like we have very few human resource employee, which is at the right-hand side. So by using this bar chart, and then like we can start seeing the kind of variation. And the same thing, like we can also use maybe like bring, let's say like a male and female gender, or we can even bring like attrition status or something. So let's just go here. Let's say like I'm gonna start from here, summary view, and here's the job role right here. And then I'm gonna just click on the chat icon. And then it's already sorted by using this like a sort by here. And then from here, like what I can do is I want to see any difference between male and female. So maybe like we can assign using the color, assign a gender, and then like I can just do like kind of a side by side. And then looks like, for example, manufacturing directors, there's not much difference between the male and the female in terms of number of employee. But laboratory technicians, it looks like there's a huge gap there. And then like we can see, for example, is this like I'm gonna just take this color out. You can use either color or repeat by. So let's say, for example, like I wanna see by the job, what's one more question here? Oh, attrition status. Attrition status, let's say here. So this is attrition is like the whether the employee, any given employee has quit or not. And then like we can see that these are the people who quit. And then so like laboratory technician is the number one, and then sales executive number two, and so on. And then so there's a slightly different sort of like a variation among the people who have quit or people who have not quit. But basically, like I broke them down by using either the color or repeat by, either way, or you can do that at the same time. So for example, if I bring the attrition instead, then like we can see as here as well. So it really, it's up to you, like which one makes it easier, which one makes it harder to see. This is all about like understanding the variation, like what is any difference between the male and female, between the people who quit or not, in terms of job roles variation. Okay, so those are the how to visualize in the variation of the data. But from here, the second question, right? There are two principal questions. The first was about the variation. The second is correlation or association. So what is association and correlation? So these are like basically a relationship where changes in one variable happen together with changes in another variable with a certain rule. So these two are very similar, and so I'm not sure like it's worth like differentiate these two in this particular seminar, but they are different. So like association is more like kind of think of it as a parent or umbrella. And so any type of relationship between two variables. And then correlation is a certain type of association. And usually it kind of like it tend to have like a linear relationship in terms of statistics, the world of statistics, between two numerical variables. So, but the key here is to me, especially, is that we want to basically find like a relationship between two variables. Not just a relationship, but it's a kind of with a certain rule, and then or like the value change in the two variables happen together kind of relationship. And why is that? Is that so? For example, association is think of it as like let's say like we have the country. And if the country is different, let's say like from US to UK, when you compare those two countries, and then the question is monthly income also change. And that means there's some kind of rule between monthly income and country. So like country change and monthly income change. But the country itself is a categorical, it's not numerical. So it's not like US, UK, Japan has an ordinal relationship or continuous relationship. So like we can compare only like between those two, whatever the two things. But then here is the important thing is like when the country change and the monthly income also change. That's here is like the association we're talking about. And the correlation is like now, like when let's say like when we have the monthly income and age, those two numerical variables, and then let's say like if the age becomes older, and then the monthly income is getting higher. So if we happen to have this kind of relationship, and then like we call this as a correlation. Correlation has a different type of correlation. So if you one value increase and then like we tend to can expect the other variable decrease, then that is a strong negative. I mean, it doesn't have to be strong, but like that's a negative correlation. And then like it's a positive, meaning one value increase and the other variable increase. So like they happen to increase together. And then there's a degree of strength or weakness. So for example, there's a correlation. We can calculate a correlation by using correlation algorithm. But let's say like when you got usually like numbers start from like -1 to 1. 1 is the strongest positive correlation, and the -1 is the strongest negative correlation. And then in between, which is a 0, so that means there's no correlation. So it's almost like it doesn't matter if the one variable increase or decrease, doesn't matter the other variables change in the other variable. So why these are important, right? So like we're gonna start visualizing this, but like why we have to spend some time like understanding this kind of association or correlation. So the variance is something like this, right? So basically the values vary. So like monthly income can change, in different range, and then so let's say like monthly income is like starting from 1,000 to 20,000 in this organization. And then when you want to ask the question like, hey, how much the income will be, then it's hard to answer the question because it varies. It's a huge variation. So that is called uncertainty. Now, if we can find a correlation between, let's say, like monthly income and the working years, like this, right? And this seems to be like a very strong correlation between these two variables. Then we can answer the question that, if we're working if working years is 20 years, the monthly income would be around about $15,000. So what just happened here is basically we reduced the uncertainty by finding this correlation. So by using the working years. So this is why like it's very important to find a correlation between the variables. And association is also same as well. Like sort of like let's say like when the category change, in this case, country change, and then the monthly income, the range of the monthly income, or the variance of the monthly income, also like it's easier to predict, right? So because US should be like higher, the Japan is kind of lower or something like that. So if we can find strong correlations or associations, then it makes it easier to explain how monthly income change, and it makes it easier to predict what monthly income will be based on the given variable values. And then one thing to note though, the correlation is not equal to causation. Causation is a special type of correlation. But if we can confirm a given correlation is causation, then we can control the outcome. This is the control part. I'm not going to go into the detail of this correlation causation thing here, and I'm not going to go into the detail of. I'm not going to go into not even the detail, even the brief of how to test if this correlation is causation, that kind of stuff. But there are a way to do it. But today is we want to build a hypothesis, right? So let's stay there. So the visualizing association and correlation, that's what we wanted to do. Okay. So there are a bunch of different charts, and I'm sure there are more, for example, the bubble chart. But let's talk about these chart types. So how to choose the right charts to understand the association or correlation. And it depends on the combination of the data types. So combination of data types, it can be like category versus numerical and so on. So I'm going to go one by one. So let's start with category and numerical. Okay. So in that case, these are the charts that can be useful. So we already look at that it's actually we kind of have done already, because this one is like a job role and monthly income. Like we wanted to understand like how the job role, the relationship with monthly income, and we use a histogram and then like assign job role to color. And basically like what we're doing here is try to see the association between job role and monthly income. But it was kind of hard to see sort of like a pattern here clearly. So therefore, we use a density plot. But then like that helped, that made it easier to see the association between these two variables. So we have already done. And so like a density plot and histogram can be also used to understand the association association as well. But typically this box plot is more useful. Depends, some people like it better, some people don't like it less, but typically like box plot can be very useful in terms of understanding between the relationship between those two variables. So to understand the box plot, so like I assign from like a monthly income from 1,000 to 10,000, and then like I put like all those employee here. And then to understand a box plot, we have to understand this thing called a quartile. It's like a 25% or a percentile of 25 percentile, 50 percentile, 75 percentile, and so on. So then the four groups or quartile is basically like after you split into 4 groups, then each group has equal size compared to others. So like after divide, in this case, each group has 3 employees. Right. And then like we want to see like where those dividing lines are. And then those are the lines that can be called like 1Q, the first quartile, or 25 percentile, or second quartile, third quartile, and so on. And once we get these values, then the box plot is basically representing those numbers. So what that means is the first quartile, and then the second, third, and then the second quartile, which is a 50 percentile, which is basically the median, right? So the box plot is the box part of the box plot chart is really representing these 3 numbers. Okay, and then at the bottom and at the top, both of them are representing minimum value and max value respectively. Okay, so that's what the box plot really is. So here, like let's take a look at the data. So let's understand the relationship between the monthly salary, monthly income, and the job role, and also like let's try to see the monthly salary and gender. So go back to here, and then let's select the box plot. And the x-axis can be the category, and the box plot case always x-axis is category, and the y is the numerical. So here, let's start with, let's say, like a gender, and the y-axis can be monthly income. And then we want to see like if there are any difference between male and female, and then looks like a female median is slightly higher, and then like max value also slightly higher. By the way, this can be visualized by using a density plot. So here, if I change this color to gender, and then x-axis is monthly income, and then there's a difference like male and female. Basically, this is what we are looking at. This is the same data we are looking at by using a different chart. So again, there's no rule of sort of like you have to use a box or you have to use a density plot, that kind of stuff. Whatever works for you in terms of like understanding that difference between those, difference in the variations or the association between a gender and a monthly income in this case. Okay, so then if we change the x-axis to monthly income, not the monthly, sorry. We are looking at a monthly income on the y-axis. So like, let's say like a job role, and then, whoa. So x-axis now the job role, and the y-axis monthly income. And it seems like there's a difference among the job roles. And then like, this is kind of hard to see. So like, let's sort by, the sort option is there are different things. So like, default is the median. You can change that like average or others, but I'm gonna just keep it for median for now. So now like we can see manager, research director, those two are sort of like, if you know that job role is these two, then you can guess their monthly income within this range. And if you know that job role is sales representative, then you can guess or estimate what would be their salary range or some monthly income. And then it looks like there's 1, 2, 3 sort of different groups. But again, this is the same information visualized in a different way. So like if you use a density plot, and then you can assign a job role. And basically this the information. So like this is by using density plot, you can change that to histogram as well, or you can change to the box plot. Again, it's up to you, but this is where we use. And also like a box plot, and there's a violin plot as well. And then the violin plot is nothing but is a combination of box plot combined with a density plot. So the density plot is about sort of like a distribution, like a smooth line of the distribution. And then another cool thing about the violin plot is this dotted line, which has the average also. So not just median, but you can see the way that average or like a mean values are. Okay, so I'm gonna just go. Sometimes like a violin is great, but a violin seems to be sometimes too much information. So I personally prefer box plot, but again, it depends what works better for you. Okay, and then the next one is the combination is the numerical and the numerical, right? So this one is a really we are getting into more like a sort of like formal correlation stuff. So by using scatter plot, usually like you have a numerical variable and another one is a numerical variable. You put those two on the x and y axis, and then each dot represent usually each line. In this case, the employee at the intersection of x and y. Okay, so let's start visualizing. So first, we want to see the correlation, or like if there's any correlation between monthly salary and age. And the second, we're going to see like monthly salary and total working years. And then we want to see those are any difference in terms of correlation among the job roles. Okay. So let's create a new chart, and I'm going to select the scatter plot. And the x-axis, let's say age. And then y-axis, let's say like a monthly income. And then, so now here, each dot is each employee or each role, right? But in this is employee. And then it seems like when you have them, when you get older, the salary monthly income tend to go higher. And then there's some kind of like a correlation here. And the cool thing is here is like you want to draw the trend line. So like from the y-axis menu, there's a trend line. And then you can select the linear regression and then click on the apply button. If you are not familiar with the linear regression, I recommend you to take a look at the past online seminar like where I presented introduction to the linear regression with 2 sessions. Okay, but now here is the one important thing here is like you can see multiple metrics, but one of them at the bottom is called correlation. So it says 0.49. So that number indicates the strength of the correlation. So we can see like it's a positive, right? It can be negative, but in this case, it's positive. That means the higher the age, the higher the monthly income. And then of 0.49, so it's relatively strong, but it's not like strong, like for example 0.9 or 0.8 or something like that. So, but so that's the relationship between these 2 variables. How about the total working years and the monthly income? So I can change the x-axis to total working years. And then here is a x-axis now, the total working years. So the total working years and age seems to be kind of the same kind of things, but the total working years, I mean, depends like how many companies did you work before, or like how many years you work at college, maybe the difference between age and total working years. But nonetheless, let's take a look at the correlation, the strength of the correlation. Here is 0.77. But this means total working years, so how many years you work at this organization is more useful than the age itself in terms of predicting the monthly income, right? So because 0.77 is much higher than the 0.47, I forgot the exact number, but much higher here. So that's what we can we are looking at here. And then the next question is this kind of correlation or is it same among the job roles or the difference among the job roles? As we have seen already that based on the job roles, the salary range is different. So maybe, for example, in manager group, the salary, this kind of correlation might be different from, like, let's say, sales rep. So let's separate the data into different sections, different clusters, and then try to see this relationship. So for that, like we can use a repeat by. Then I'm going to assign a job role. And now basically what we are looking at is the scatter plot for each job role group. So for example, let's say here, the healthcare representative, and then we can see that there's a correlation, but it's like a 0.65. And then like, let's say like a manager. So these are the people, right? Like who are making a higher salary, and a correlation 0.56. And then research manufacturing director 0.66. So depends which group, and then there's a different correlation there. So for example, sales representative, this is like 0.45, which is much smaller than the others. So there is a correlation, but compared to others, so it's much less. And then it doesn't even make much difference, like in terms of like a 0 year to 20 years. And then, but for example, when you look at like healthcare, and it looks like it makes a difference, although there are no data after 20 years in a sales representative, which is kind of interesting. But anyway, so like by using this repeat by, then like we can even like go deeper in this kind of visualizing this relationship. This repeat by though, there's a little bit of setting under the layout. So for example, if you don't want to use the same scale, like right now the scale is 0 to 40 years, but like we see a sales representative doesn't even have anybody who's working more than 20 years. So like I can disable here, and then even like a y-axis also like unscale it. Then now like each chart has its own scale for x and y axis. And this might make it easier to see the relationship. Though now the scale is different, so it's kind of like you can't compare to the next ones each other, but nonetheless. you can see the sort of like relationship in more detail, sort of like a more zoomed in way. Okay, so that's the scatter plot, and then this is the last one, which is the last combination, which is the category and category. Okay, so the category and category, the way we can visualize the relationship between them is to usually you calculate the size, in this case, the number of rows for each pair of the categories, right? And then you can visualize the sort of like the size itself, but also even better is that you calculate the ratio against the total size. So, and then these are the two types of charts. Usually like, not usually, but sometimes you can use a bubble chart as well. But I listed up like stack bar and heat map. And especially I think stack bar to me is very useful because it's, more familiar chart for many people. And then it actually does a really good job. So like I want to use a stack bar chart here to go through this. So 4 questions. Number 1, job role and education. Number 2, job role and attrition. And then number 3, job role and monthly salary. And then number 4, monthly salary and total working years. And if you have noticed though, like, so this job role and, education and job role, which is very simple and straightforward, because both of them are categorical. So let's take a look. So I'm going to select the bar chart, and then let's select a job role as x-axis. And then what we can do is using the color. So in this case, education field. And then we can see, for example, sales executive has this like a education field of marketing. So the marketing is the green color. And you can see the green color in only certain job roles, like manager, sales executive, sales representative. And on the other hand, this like a human resource, like which is blue color, you can find it in the human resources and the manager, which is kind of like expected. And then this is basically like calculating the numbers or the size, like in this case, number of roles or like a number of employees. But we can calculate the ratio of each education field in each job role. So how we do it, so like you go to the y-axis, because we want to change the y-axis scale. So from the y-axis menu, window calculation, and then select the percent of as a calculation type. And then click on the apply button. And basically each bar becomes like kind of at the same height, because now like y-axis is from 0% to 100%. And then we can see, for example, human resource, almost across the half of the people, like 40% of people have taken a human resource education and so on. So this is nothing so special. But now the next question is the attrition. And attrition is interesting because here, which is logical data type, and it has a true and false. And this attrition is, even though it says logical, logical data type is a part of a certain type of the categorical, which has only 2 values, and then they are true and false. Okay, so that means basically, again, like we can use this like a stack bar chart. And then now this time, like I'm going to change the color from education field to attrition, true or false. And then now like we can see, for example, when you see that blue color, it says true, that means the people who have quit. And it looks like a sales representative tend to have higher percentage or ratio of people who quit the job. And then if you have a research director, have very less percentage or ratio of people who have quit the job. So we can see that. So basically we are comparing, we're trying to understand the relationship between job role and attrition, right? So now the next question is job role and monthly income. And it sounds like monthly income is numeric. So like numerical and then the categorical, we thought like that is density plot or box plot. But actually you can use bar chart 2. So this becomes might be too complicated if you just get into it, but this is actually quite useful. So how are we going to do that? Well, so I'm going to change the color to monthly income. And this is numerical. So therefore, when you assign numerical data to color or x-axis, it automatically categorizes into categories. So what happens when you click on this equal width is basically the same thing as histogram. It divides into the same widths, same range. In this case, 5. If I change that to, let's say, like a 10 or something, you have more ranges, but each range is pretty much the same width or same length. And then now we can see, for example, manager and research director has more people at this bucket or the group of monthly income ranging from 18,000 to like 20,000. These are the two super dark color of the monthly income group, so research director and manager. So by doing this, so now all of a sudden, between the job role, which is categorical, and monthly income, which is numerical, what we're doing here is basically sort of trying to understand the relationship between the categorical and categorical. And that means, so now the color is even the numerical column, but a variable, but it's as a categorical, right? So that means we can even bring this x-axis to numerical, which is I think the last question here. I forgot what's the question. Visualize monthly salary and working years. So let's say if we change the x-axis total working years, assigned to total working years, what is going to happen is, again, when you assign a numerical to x-axis, you automatically categorize it. If you don't want to see the categorized, then you can change to number or integer as it is. But then that means you have tons of bars because this is a working year. So let's say 40 years or something. So you're going to have 40 bars. But in this case, just by using equal width option, it's bucketed into 5 groups. So now all of a sudden, we are looking at this is similar to this chart, except I'm going to deselect the job role thing. So we are looking at total working years, monthly income by using the scatter plot as a kind of raw value, as a numerical values. But here we converted the total working years and the monthly income into the category or in a certain set of buckets. And then we are looking at the relationship between them. So here it's for example, total working years, a longer, more working years. And then the higher salary is a darker color means higher salary. So those type of people are more concentrated in this area and so on. Okay. So, and then if this is different among the job roles, you can break down by the job roles and then see, for example, manager and then research director. Obviously, there are a lot of people making more money, but then also, it doesn't, in this case, it doesn't matter. Obviously, the people are working greater than 8 years, but then from more than 16 years, they start making a lot of money. And then research director too. So there's not much difference after 16 years in these two categories. Where sales executive, it makes difference between 8 years to 16 years and 24 years and so on. So this type of the relationship can be visualized better by bucketing or binning or categorizing the numerical values as well. Okay, so that's a stack bar chart. And I think that's it for today's topic. It's 12 o'clock Pacific time. It's so perfect. So I'm going to stop here for today's session and then open up for Q&A. If you have any question, please ask by sending the chat window